Hi all, welcome again to the topic on Spark transformations and actions. In the previous videos, we were looking at the lazy evaluation and the most commonly used transformations and actions. So if you are new to this video, please refer to the previous videos in order to get an insight of the current topic. So in this video, our focus will be mainly on two important transformations, namely the repartitions and coalesce. So let us try to understand one by one. So what is repartition? Repartition is nothing but an important concept in PySpark, which is used to increase or decrease the partitions which are used for processing the RDDs or data frames in the PySpark model. So most of you would be aware that PySpark model is based upon the partition of the data and processing the data among those partitions. So this repartition, which actually helps to increase or decrease these particular partitions based upon the requirement and the data size. So let us try to understand the two important parameters which are used in the repartition. The first is the num partition and second is the call. So the num partition, it is nothing but an integer which can be used to specify the target number of partitions. Okay, so how many partitions do you want for this particular data? So it is a column, it will be used as a first partitioning column. Okay, if we do not specify that, then the default number of partitions will be used. Second is the column. So if you want to partition based upon any particular column, then you can provide this particular input. So let us try to create some examples and understand better about the repartitioning. If you have followed my previous videos, you would have come across the dataset which I have been using for this Spark transformations and actions, which is the airport dataset. So this particular dataset, it contains the airport ID and city and which are all the states the particular airport is present and what is the name of the airport. So using this dataset itself, let us try to understand the repartition concept as well. Okay, so let me move back. So here what I have done is I have created a data frame by importing the airport.csv file, and in the previous videos I have explained about how to import the CSV file into a data frame. So in this video, let us just run it. Hope you all have an idea. If not, you can refer to my old videos. So I'm trying to load the airport.csv into the data frame. Okay. Okay. If you see here, I have airport ID, city, state, and name. This is the print schema. If you want to have a look at how the data is, you can just run it with the help of df.take the first 10 rows. It actually shows the first 10 rows. Okay. So with this current data frame, I'm invoking the get num partition. So in order to understand how many partitions I have, I'm invoking that with the help of rdd dot get num partitions. Okay, so this will get the number of partitions which I have for this data frame. So this is actually a data frame. So in order to convert that into an RDD, I'm using dot .rdd and I'm running it. So if you see, I have one partition. Okay, so based upon the data or based upon the requirement, if I have to increase the number of partitions, then what can I do? If I call this repartition, it will actually create the number of partitions which I'm giving the input. Okay, so let us run this. So the reason why I have assigned it to a new data frame is that uh, so as you know, Spark is immutable. So whenever you repartition, the already existing data frames or things remains the same and a new one will be created. So that's the reason. So let us try to view the first 20 rows of this particular data frame. So if you see here, this is the first 20 rows. Okay, and let us now try to get the number of partitions for this C. So I'm getting the number of partitions. If you see here, so I'm getting it as 5. So initially it was one partition and I have repartitioned it and made it into 5 partitions. Okay, so the first parameter which we saw is the number of partitions which we required, and the next is based upon the column. So here the repartition, I'm giving it as I want it as 3 partition and it must partition based upon the state. Okay, so let us try to run this. So if you see here, Considering state as a first priority, it is actually partitioning my data based upon that. Suppose if I give two columns, then the partitioning will be based upon these two columns. Okay, I think you are able to understand the difference between the data, the way it is partitioned. Okay, so when I try to get the number of partitions for this data frame, it is 1, but when I try to get the number of partitions for the C, it is actually 5. Okay, so what actually the repartition does? So repartition, it is used to increase or decrease the number of partitions in PySpark. So the repartition provides a full shuffling of the data. That is, it will shuffle the entire data, and it is an expensive operation since the partition data is restructured using the shuffling data. So let us now try to understand about the next important function, which is coalesce. So the coalesce function is used to reduce the number of partitions in the data frame or the RDD. Okay, by reducing, it avoids the full shuffle of the data and shuffles the data using the hash partitioner. This is the default shuffling mechanism which is used for shuffling the data. This coalesce function, it avoids the full shuffle, whereas the executors can keep the data safely on the minimum partitions. So similar to the repartition, we have the num partitions as a parameter for the coalesce function. Okay. So this returns a new data frame that has exactly the num partition, number of partitions which is specified. So let us take another example. Using this par context or parallelize, I am taking a few set of numbers. Okay. So let us try to run this. Okay. And I'm getting the number of partitions using the get num partition for this RDD. If you see, it is 8. Okay. When I try to invoke the coalesce function with the number of partition as the input, I'm creating a new RDD, and here I'm getting the number of partitions, and you can see it is 4. So the number of partitions has been reduced from 8 to 4. So what actually this coalesce do? The coalesce function works on existing partition and avoids full shuffling. Whereas if you consider repartition, we discussed like it will reshuffle the data in your RDD to produce a final number of partitions. Since coalesce does not do any shuffling, it is optimized and memory efficient. It is only used to reduce the number of partitions, whereas the repartition, we can either increase the partition or decrease the number of partition. The data is not evenly distributed in coalesce, and the existing partition are shuffled in coalesce. So there is an important note which must be considered. So which is here is the basic principle of Spark RDD, as I told earlier, so it is immutable. So the repartition or coalesce will definitely create the new RDD. So wherever cases you saw, we have actually created a new RDD whenever we wanted to increase or decrease the partitions. Okay, so the base RDD will continue to have existence with its original number of partitions. So based upon our discussion, you can see that both work on decreasing the size of a partition. There could be certain examples or scenarios where you want to use only coalesce or repartition. Similar to that situation, one particular example I can say is when you want to filter your data before writing it, then repartition is much more suitable than coalesce, since coalesce will push down right before the loading operation. Okay, for example, I have a load method followed by a map, then a filter. So here I'm using a filter in order to filter certain kind of data. For example, in the dataset, if I want to, in the output dataset, if I want to filter it for one particular state, I can use filter, and I'm calling the class of one dot save. Okay. So what will happen? This actually get translated to this. So this means that all your data will collapse into a single partition where it will be filtered. So losing all your features of parallelism. So this happens even for very simple filters, like if you give some values equal to columns equal to some value. Okay. This doesn't happen with respect to repartition. For example, when you give repartition like this, so what will happen in this case? Filtering happens in parallel on the original partitions. Okay, so the repartition algorithm does a full shuffle of the data and creates equal size partitions of the data. So the coalesce combines existing partitions to avoid full shuffle. So coalesce works well for taking an RDD with a lot of partitions and combining partitions on a single worker node to produce a final RDD with less partition. Whereas repartition will reshuffle the data in your RDD to produce the final number of partitions as per your request. So the partitioning of the data frame seems like a low level implementation detail that should be managed by the framework, but it is not. So when filtering the large data frames into smaller ones, you should almost always repartition the data. So you will be probably be filtering large data frame into smaller ones frequently. So get used to repartition. Okay. So hope you got an idea of about what is repartition and coalesce. Thanks for watching this video. Have a nice day.